Find the value of k for which the equation 5x squared minus 2x plus k equals 0 has exactly one solution. So the words exactly one solution. This means that we have to apply the discriminant for a quadratic function. So firstly, let's remind ourselves what the discriminant is. So, for a quadratic function f of x equals to ax squared plus bx plus c equals 0, the expression b squared minus 4ac is called the discriminant. Now here what we have to appreciate, in this expression, b is the coefficient of x, a is the coefficient of x squared, and c is the constant. Now, the discriminant tells us how many roots there are for f of x, so for the quadratic function. We've got three different cases. If the discriminant is strictly greater than 0, this implies that there are two distinct real solutions to this quadratic equation. If the discriminant equals to 0, this implies that there is one repeated real solution to the quadratic equation. If the discriminant is strictly less than 0, this implies that there are no real solutions. So in our case, for this quadratic on top to have exactly one solution, we have to set the discriminant to be equal to 0. So now, 5x squared minus 2x plus k equals 0 implies that the value of a, the coefficient of x squared, is 5. The value of b, so the coefficient of x, is minus 2. And then the constant term, c, equals to k. So now substituting these into the discriminant, b squared minus 4ac equals to 0. Again, we want the discriminant to equal to 0, since we want this quadratic equation to have one solution. So this implies replacing b with negative 2, b squared becomes negative 2 to the power of 2. Take away 4 multiplied by 5 and then multiplied by k. This is what negative 4ac becomes. And we want to set it all to be equal to 0. Now simplifying, we get 4 take away 20k equals to 0. And then solving this very simple linear equation for k, we get that 4 equals to 20k, which implies that k equals to a fifth. So only if the value of k is a fifth, this quadratic equation will have one solution.